Okay, so now we have to find the derivative of tan cube theta and sec square theta. So we can simply apply the differential on both sides of the equation, d by dx tangent cube theta secant square theta. And the angles right over here are actually present in only one power, so we do not have to worry about them because derivative of x with respect to theta would actually be 1, so we do not need to worry about it. Okay, so this is my first function and this is my second function. So the second function as it is, sec square theta, the derivative of the first function plus the first function as it is, the derivative of the second function. Okay, we are having sec x. Okay, so we know the derivative of sec x is actually sec x dot tan x, but over here we have secant square theta. Okay, so you have to keep in mind we have sec square theta right over here multiplied by what would be the derivative of tan cube theta. The derivative of actually tan x is actually secant square x. So the derivative of tan cube x would be, this is the power right over here, right? So the power would be separated and we will be left with tan 3 minus 1 square theta, the derivative of the angle. Now what is the angle? The angle is anything which is present under the power. What is present under the power? Tangent. So the derivative of tangent theta. Okay, so I hope you get the point. Again, it is same in this step. So tangent cube theta is as it is, okay, multiplied by, this is the power. If we are having a power in a derivative, we have to actually separate it from the function. Okay, so what I'm trying to say is d by dx x square. So how I can write it? It can be actually written as 2x 2 minus 1, which is equal to 2x power 1. So secant square theta. So this is 2 right over here. So the power would be separated. Secant 2 minus 1 is actually 1 theta multiplied by the derivative of the angle. Now what is the angle? The angle is anything which is present under the power. What is present under the power? Secant theta. So the derivative of secant theta. Okay, so I hope that makes sense. Secant square theta multiplied by 3 tangent square theta multiplied by tangent theta. Now, what is the derivative of tangent theta? It is actually secant square theta plus tangent cube theta multiplied by 2 secant theta. And what is the derivative of secant theta? It is actually secant theta dot tangent theta. So secant theta dot tangent theta. So now let's just multiply these terms. Secant square theta would be secant 4 theta. Okay, multiplied by so let's just keep this 3 as a constant over here. So we are left with tangent square theta plus, okay, so over here we have tangent and all of these terms are actually being multiplied, so that's nice. So tangent multiplied tangent is tangent 4 theta, then 2 is the constant multiplied by secant theta would be secant square theta. Okay, we know that some of the things are common over here. Secant square theta is the lower power and tangent square theta is the lower power right over here, and the constants are not common. So we are going to take out secant square theta and tangent square theta. So we are left with 3 secant 4 theta divided by secant square theta gives out secant square theta, and tangent square theta is cancelled, plus 2 secant square theta and secant square theta are cancelled. Tangent square theta divided by tangent power 4 theta would give us tangent square theta. So this is the final derivative of tangent cube theta dot secant square theta.